Now we're going to look at inductive versus deductive reasoning. For this example, we're going to look at how to solve something using inductive reasoning, then using deductive reasoning. Now, it says, what conclusion can you make about the product of an even integer and any other integer? Well, the best thing for you to do with inductive reasoning is to just try it and see what happens. So this is what they do here. And if we look, when we multiply -2 times 2, we get a -4. -2 times -4, we get 8. 1 times, or -1 times 2 gives me a -2. -1 times -4 gives me 4, etc. So we just keep trying it until we see some sort of pattern. And that's what inductive reasoning is. So if we have an even integer and any other integer, it looks like no matter what, all of those numbers have in common are they're all even integers. So our conclusion would be, or our conjecture would be, an even integer times any integer gives us an even integer. Now we want to look at it in terms of deductive reasoning, which is a way to prove that it's true all the time, or to be more specific rather than just looking at a pattern. So if we say n and m are any integers, we're going to use deductive reasoning to show that this is true all the time. So if we call 2n the even integer, any number multiplied by 2 will be even. If we then multiply 2 times n times m, this is an even integer and any integer, and in that case 2nm will also be an even integer because it will be 2 times whatever this integer is here. So therefore we can conclude that the conjecture we made earlier is true all the time. So the product of an even integer and any integer is an even integer. Again, with inductive reasoning, we don't know that it's true all of the time. With deductive reasoning, we basically prove that it is true all the time. Here's another example, same type of thing. If I add a number and itself, well, if we think about this carefully, if I do 1 plus 1, or 2 plus 2, or 3 plus 3, or 4 plus 4, doesn't matter. We're going to get double what we had before. So basically, if we were to do inductive reasoning, we would just start trying a couple of things. 2 plus 2 equals 4. We could even do -3 plus -3 gives me -6. -5 doesn't really matter. Plus -5 equals -10. In all of these cases, this is 2 times 1. This is 2 times 2. This is 2 times -3. This is 2 times -5. It ends up being twice what it's supposed to be. And then for deductive reasoning, what we would do is we would say n represents a number. And we would state that n plus n equals 2n. Therefore, no matter what this number is, it's always going to equal twice what the number is. So if we look again, the sum of a number in itself is twice the number. That's the conjecture we could make with inductive reasoning. And then to prove it's true all the time, we just say n plus n equals 2n. Shows that it's always twice the number. Alright, now we're going to look at this chart. If you look, we're comparing the depth that a seal is going to and the number of strokes they need to use. You notice, in general, if we look at the pattern, as the depth increases, so does the number of strokes. So the northern elephant seal requires more strokes to surface the deeper it dives, which should make sense because they have to swim further. And this would be more of an inductive reasoning because basically we're not looking at specific data, we're looking at the pattern and the way the data is going. So this would be inductive reasoning, because again, we're looking at a pattern. For the second one, it says the northern elephant seal uses more strokes to surface from 250 to 60. Well, if we look at 60, that's right about here. Not many strokes. At 250, it looks like it's a lot more strokes. So we're using specific data, and we're proving something's true all the time. So this would be deductive reasoning. And again, inductive reasoning for the first one because it's based on a pattern, and deductive because we're looking at actual values rather than a pattern. And for this last one, it says write another statement about the graph that we just saw, and then use deductive reasoning to write another statement. So one example of an inductive reasoning would be the more strokes it takes for the seal to surface, the deeper it dove, which makes sense just looking at the pattern. And for deductive reasoning, again, similar to the last statement, we know that at 190 meters they're going to use fewer strokes than if they were at 410 meters. And again, we're using specific data here, so it's deductive reasoning. And that's it for this one. Thank you.